sine x, comma, cos x, and many others. So we're going to look at the integration involving odd numbers, odd powers of sine, cos, tan, cot, like that. That's what we're going to talk about. So we want to look at those, how do we handle such a kind of the odd powers. So when dealing with odd powers, you use the Pythagoras theorem. When dealing with the odd powers, of sine x and cos x, we use the Pythagoras theorem. Recall that cos squared x plus sine squared x was equal to 1. So remember that first identity from the trigonometry. So if you want to have cos squared, what is cos squared x? Cos squared is the same as 1 minus sine squared x. What about when you find sine squared x, the subject is the same as 1 minus cos squared x, how it was being derived, and we came out to that from the trigonometry. So when we are dealing with the odd powers of sine and cos, we get use of cos squared x and sine x squared from that expression, from that first identity, as we are going to be looking at how we are going to be proceeding with them. So we are going to start with the examples. How we are going to be dealing with that. So we're going to start with the first example. We're going to start with example 1. It goes integrate sine cubed x dx. So we have said integrate sine cubed x dx. How do we handle such a kind of a number? You can see the power is already odd. And when you are getting an odd, we get use of the Pythagoras theorem, as we have already been notifying it. So, solution. So we are saying integral of sine cubed x dx is the same as integral of sine x sine squared x dx. What do we do with the sine squared? With the sine squared, we are going to create it in terms of the other trigonometric identity which we have said. This becomes the integral of sine x into, where there is the sine squared, you are going to say 1 minus cos squared x dx. So we have already put into that. So now observe, when I differentiate a cos, I'm getting associated to a sine. It means it's a function and its derivative. So from there you go ahead and say let u equals cos x. So can we differentiate? When we differentiate a cos, we are going to get a negative sign, as we looked at in trigonometry. Du equals negative sine x dx. Can you make dx a subject? What is dx alone? Dx becomes negative du out of sine x. This implies that integral of sine cubed x dx is the same as integral of sine x into 1 minus a u squared times, where there is a dx, you are going to have negative du out of sine x. Sine x disappears. What do you remain with? We are going to remain with integral of negative into 1 minus a u squared du. Then from there, you are free to push in as you are going to be opening the brackets. So can we push in? This becomes integral of a negative times a 1. What do you get? We get a negative 1 times a du. We just get a negative du. Come, a negative times a negative, plus what do we get? We get a positive. We get a plus integral of u squared du. So when integrated du, what do you get? You get a u. So we are going to get negative u plus a third u cubed plus c. Recall, what was our u from the start? Our u was already a cos x. So this becomes negative cos x plus a third cos cubed x plus c. Therefore, when you integrate sin cubed x dx, you are getting negative cos x plus a third cos cubed x plus a constant of integration. That one becomes our exact answer. That's the first example which we have dealt with when we are dealing with the use of the odd powers. That's what we normally come out with. So we are going to proceed to example 2. Example 2. That was the first example. And somebody who has not got well on the first example, I beg you to lend me your biological instruments of volume such that we can easily get very well the second examples. And the moment you calculate, the more they become more and more enjoyable. But if you don't calculate, I want to assure you, they will not become enjoyable to you. So let's move to example 2. Example 2. It goes integrate sine power 5x dx. Now you can see the power is going on increasing. We started when the odd power is the power of 3. Now we are moving to the scenario when the power is of 5. How do we deal with this? Solution. The same story, we get use of the Pythagoras what? Theory. So this becomes integral of sine power 5x dx is the same as integral of sine x, then sine power 4x dx. Now you can see sine x times sine power 4, you're going to get sine power 5. Now this one can be having an element. This is the same as integral of sine x into sine squared x, the whole of it squared dx. Plus, are you getting that attempt? So that when you say sine squared power squared, you are getting sine power 4. This becomes integral of sine x into, why you say sine squared, bring the other attempt, which is 1 minus a cos squared x squared, like that. Then we say, to have already closed the bracket, we say dx. Now, from there, when I differentiate a cos, I'm getting something related to outside, which is a sine. So we shall say, let u equals cos x. Then we differentiate du equals negative sine x dx. Make dx the subject. What is dx? Dx becomes negative du out of sine x. We go back. This implies that integral of sine power 5x dx equals integral of sine x, very good, into 1 minus u squared, again squared, times, where there is a dx, we put negative du out of sine x. Sine x was, we remain with integral of negative into 1 minus u squared squared du. So what do? We expand that one 2 times. This one, when you expand it, as I've been doing several scenarios of expanding, we're looking at expanding integral of the negative into 1 minus u squared, again squared du. So how do we expand that? This becomes integral of negative into 1 minus 2u squared plus u power 4 du. So what do? We push in the negative with respect to u. We are integrating everything with respect to a u. So this becomes what? It becomes integral of negative du plus 2 integral of u squared du. And negative times the positive becomes minus integral of u power 4 du. So what do? We get negative u plus, add 1 divided by the new power, 2 out of 3 u cubed minus 1 out of 5 u power 5 plus the constant of integration. But do we know our u? Do we know our u? Our u is already a cos. So we say therefore integral of sine power 5x dx, we are getting negative cos x plus 2 out of 3 cos cubed x minus 1 out of 5 cos our 5x plus the constant of integration. That's how we can calculate such kind of the numbers. We are going to be doing several examples until when we come out with the exact thing in our heads and we know the applicability of these numbers. Remember, in an exam, these numbers are there. You will not sit for an exam and you will not find such kind of the numbers. They are always there. They are always there and very simple for you to pass. So long as you are very attentive and very keen for you to practice them. Continue practicing. The more you practice, the more you become perfect in them. But if you don't practice, I want to assure you, the little even which you have in the head will simply evaporate from you. So my colleagues, fellow students who are here, students, I beg and I beg, whenever you are, just go ahead and practice. Practice, get more books, you can get understanding, pure mathematics, you can get Backhouse 1, Backhouse 2, you calculate several numbers. Like if you go to Backhouse 1, start with chapter 1 and calculate all these numbers. Chapter 1, we are going to do several numbers on this, so that at the end, you can easily become more and more perfect. So let's move to example 3. It goes integrate cos cubed x, integrate cos cubed x, or cos power 3 x, cos cubed x dx. So how do we handle such a kind of a number? If a number comes in that way, how do you treat that number? How do you go ahead to simplify such a kind of a number? How can you do that number up to the minimum of it? So the same story, it is the same as idea, having what we call odd powers. So you go ahead, this is the same as integral of cos cubed x dx is the same as integral of cos x, then cos squared x dx. So when you see an element of a squared, we bring in the other idea of the Pythagoras theorem. So this is the same as integral of cos x into 1 minus sine squared x dx. So same story, function and its derivative. When I differentiate a sine, I'm getting a cos. So what do? We are going to say let u equals sine x. So can we differentiate? Du equals cos x dx. Make dx the subject. Dx becomes du out of cos x. This implies that integral of cos cubed x dx is the same as integral of cos x into 1 minus u squared, where there is a dx, put du out of cos x. Cos x, cos. We remain with integral of 1 minus u squared du. So here we push in. We integrate every number with respect to u. So this becomes integral of du minus integral of u squared du. When integrate a du, what do you get? U minus. When integrate u squared, we get a third u cubed plus a c. But do we know our u? Do we know our u? Our u becomes, our u is already sine. We get sine x minus a third sine cubed x plus the constant of integration, which becomes the integral of cos cubed x dx. So this one is the how we can integrate the values of x with respect we can integrate cos cubed x with respect to x. That's how we get that one. What is important is get used of the Pythagoras theorem behind how we learned about the trigonometric phrases or the trigonometric proofs, how we did them. They are very important when we are dealing with such kind of numbers. So we are going now to proceed to another example. We're going to proceed to another example. We're going to proceed to another example. That was example 3. Now we are moving to example 4. We are going to go to example 4. So we are going to go to example 4. Example 4 goes integrate cos power 5 to x dx. I want people to be very attentive on this. It is saying integrate cos power 5 to x dx. So what are we going to do with this? What are we going to do with such kind of a number? What are we going to do with this kind of a number after being given to you? So the first step is observe the type of the power given. Is it odd? Is it even? But for this scenario here, it is an odd power. How do we relate with this? We are coming to the solution. So we get use of the Pythagoras. That means you're going to create the one which is even. So I'm going to say integral of cos power 5 to x dx is the same as integral. Can first divide our whiteboard here. It's going to be integral of cos 2x cos power 4 to x dx. This becomes integral of cos 2x. We get cos squared 2x, the whole of it squared dx. So that when you expand it, you get power 4. When you apply with this, we come out with this. So here we apply the use of the Pythagoras theorem. This is cos 2x into 1 minus sine squared 2x squared dx. Now we also come to this. When I differentiate a sine, I'm getting a cos. So we say let u equals sine 2x. We differentiate du equals 2 cos 2x dx. Make dx the subject. Dx equals du out of 2 cos 2x. So we got this implies that integral of cos power 5 to x dx is the same as integral of cos 2x into 1 minus u squared. 1 minus u squared again squared times, where there is a dx, I'm going to put our du out of 2 cos 2x. Cos 2x is, it disappears. What we remain with? We remain with a half integral of 1 minus u squared again squared du. So we try to expand that. Can we expand this? This equals a half integral of, we expand this. It is going to happen 2 times. So this is the same as 1 minus 2u squared plus u power 4 du. So we push in, we multiply in half with the integral with respect to u. This becomes a half integral of du minus a half times 2, we remain with just with u squared du plus a half integral of u power 4 du. So from there, can we integrate? When integrated du, what do we get? We get a u, we get a half u minus, this one becomes a third u cubed plus add 1 divided by the new power. When you add 1, it becomes 5 times 5. 2 times 5, you get 1 out of 10 u power 5 plus the constant of integration. What happens? What is our u? Our u is already a sine 2x. So this becomes a half sine 2x minus a third sine cubed 2x plus 1 over 10 sine power 5 2x plus c. Therefore, when I integrate sine power 5 2x dx, I'm getting, if you want to factorize out, still there is no problem with that. You can even find out, factorize when you get the LCM, but not when it is the time, just leave it like that. We say a half sine 2x minus a third sine cubed 2x plus 1 over 10 sine power 5 2x plus the constant of integration plus the constant of integration. That one is not always forget it. Even if the power is being raised to what?